robots with FANUC, you can write a piece of code into like an LS file, so you can like copy and paste just written text, and then it'll basically convert it to like FANUC's what's called TP code. So this is what I'm talking about, how there's different like languages and stuff like that. So for like FANUC robots, it's .tp. TP code is how it's referred to. Those things are pretty simple, right? Because basically you have to just feed it the instructions. And like, even if, let's say, FANUC didn't want to give you their entire instruction set on like on a flash drive, technically you could export every instruction inside of a TP program, then take that TP program and copy and paste it, save it as an LS file or whatever, copy and paste into the AI model to then teach it what the robot code should look like. Here's what its syntax should look like. Here are the instructions that you have available to be used. And like, then if you have access to like the dictionary, or when I say the dictionary, even just the FANUC user manuals that tell you what each instruction does, like the programming manuals that tells you exactly what instruction does what and what its use case is. Now you can take that information and then train that into the AI, so that way the AI has the ability of understanding each command that you give the robot. That way it has the ability of understanding each command that the robot has, and also the syntax of those commands and the use case of those different commands. And it maybe even gives some examples of when you would want to use particular commands over another. Maybe some commands are similar to one another. There has been some people who have been able to do regular structured text languages with AI and generate code that was usable, workable code. I don't think it's that far off for being able to do something like that with like robots, or at least robots where you can, output the code, you can get the syntax, you're able to load in text files, or be able to convert them from a text file to the robot native language, or when I say native language, it's runtime code. That's another thing when it comes to like programming. Like, whenever you code something, sometimes you have to generate what's called a runtime, which basically takes your codable version of a program and converts it into code that the system can operate more easily, more compact, shrinks the data. And again, this goes back to the back end of like the operating systems and stuff like that, where like the robot doesn't care like do this, do that, if this, then that. It doesn't care about those human words. It literally has like equations where each one of those things means something in the back end. Then through its algorithms, it's processing that code. That's way deeper than what I'm trying to get in this video. But yeah, this is where I really think we're at with AI and being able to utilize it in the automation industry. It's gonna be a lot more challenging with PLC. If we can do the same thing with PLC, where we can just convert structured text, ladder logic very easily, then I don't think we have any problem at all. Again, I think that's just going to be a challenge for some time. And you could also still program, PLCs in structured text. But the thing is, the industry just generally doesn't want to program PLCs in structured text, so therefore it's probably not going to really accept it, right? Like a lot of customers that if you were to try to give them, manufacturers, if you were trying to give them a structured programmed system, because a lot of technicians don't know how to program in structured text. So that would be the challenge. And also I don't really understand on an executional standpoint, like how Allen Bradley doesn't have like the ability, and all the PLCs that have the ability to do structured text and ladder logic, I don't understand how there's not basically a view option, meaning view in structured text, view in ladder logic, and it automatically just converts the code to do the exact same thing in whatever language you want to see it in, right? Maybe it's function block diagramming, and so you can basically just click view, and they have like their software has the ability to adapt the code on the back end to be able to view it in the way you want to view it. So if they do something like that, then that will definitely open up the door. And this is where I say the developers really, really needed when it comes to developing these type of systems. Because if you simply had the ability to just convert regular structured text to ladder logic, boom, no problem, done. I think that the AI is going to be very, very close to being able to execute that code, or be able to write that code. But then the next challenge is when it comes to automation and manufacturing, there's a lot of moving parts. So I think the next thing that's really going to have to happen is people are going to have to really step up in simulation softwares. They're going to have to utilize simulation softwares and just invest in them. They're expensive softwares. A lot of people also don't want to, they don't want to invest the money in the software. They can be tens of thousands of dollars a year, and they also don't want to invest the resources to create, digital versions of their systems, because there's a lot of work that goes into like making a system completely functional inside of a autonomous environment or a simulated environment. There's a ton of work that goes into that, especially when you're talking about like very complex, like material handling, custom, special purpose type of equipment. Like stuff like robotics, like that's fairly easy, because like a Fanuc robot's a Fanuc robot, and there's already simulation software's there. It's the same model number robot, or not that it's the same model number robot, but versus like if it's custom, then you have to rebuild every single nut and bolt of the machine every single time inside the simulation software. So like there's the mechanical engineering, and there's another level of basically doing mechanical engineering to create motions and animations on each individual joint that you want to move, and constrain other joints that you don't want to move from moving. So again, there's a lot of work that goes into that, but I think that we're going to have to we'll see a lot more people using it when AI makes programming easier, because now we need to test these AI programs that we just wrote with the AI, PLC programs and robot programs. We just wrote it with the AI. It's going to have to be thoroughly tested before we even try to run that in a machine, or we won't be able to run any code that is going to actuate any outputs. Or we have to go through one by one and simulate that code. So as like a PLC programmer, you have ways of being able to simulate how a system will operate, and you'd have to go through and individually test every single functionality of the system very thoroughly, and then like one by one test each output of the system, and you just have to do this process very, very thoroughly, and have like very good systems in place to make sure that like when you power the system on and you hit cycle start, that like the system just doesn't eat itself alive. Things inside of things, like these things happen anyway in the real world when it comes to automation, but whenever you have like all your code is auto written for you by AI, it becomes really easy to just download that program, hit cycle start, and then see some devastating tragedy happen with the equipment or even human safety. So like that's a big thing to keep in mind. I'm gonna do a part 2 of this one, so stay tuned. I'm gonna kind of continue on the conversation with the robots, and how I feel like AI robots, or just humanoid type of robots, are really going to have an impact in the manufacturing and automation world. So make sure you hit the subscribe button. Stay tuned for that video as well. And I'm gonna shoot that video right after this, but it might take some extra, like 1 week to get out if you're seeing this video now. So hopefully this was useful. If there's more things you'd like for me to elaborate on, let me know. I went quite a bit deeper on this particular topic, and like a lot of the nuts and bolts of everything, more than I wanted to. I just wanted to do more of a high level overview, but I went deep with it. So if you would, just let me know in the comments below if there's anything else in particular that you would like to see, and we'll catch you in the next one.